Hello, everyone. Welcome to Brainwaves. I'm Brandon Staglin, your host. Today, we're going to be talking about depression. Now, depression is one of the most commonly diagnosed debilitating brain health conditions, and it's also one of the most varied. And, as Dr. Conor Liston likes to point out, Dr. Conor Liston of Weill Cornell Medical College, he likes to point out that if you combine the different criteria for diagnosing depression in the DSM-5 in different ways, you come up with actually 256 unique different forms of depression. And it's very clear from the diagnoses and of the cause of depression in different people and the experience of different people that depression is actually many different things. So, what if doctors could benefit from research that would enable them to give more specific and accurate diagnoses to individuals living with depression, and thus prescribe the best and most effective treatment for them right away instead of having to go through a trial and error process? Well, this is exactly the kind of research that Dr. Liston is doing, and for which he's won the 2015 Imro Janssen Rising Star Translational Research Award. Now, Conor Liston is here with us today to speak with us about his research proposal and to answer your questions. So, Dr. Liston, thank you so much for being with us today. Congratulations on your award.
Thanks, Brandon. It's great to be here. I really appreciate the invitation.
Absolutely, yeah, it's great to have you. So, can you please give us, for our viewers, a 30,000-foot overview of your research proposal and the preliminary discoveries you made, and then where you plan to take it and how?
Yeah, absolutely. So you did a really good job of summarizing a lot of it just a minute ago. I think we in psychiatry today face a fundamental challenge that stands in the way of making progress in our understanding of the neurobiology of mental illness. But we're also excited because technologies are transforming the way we do this research, and I think there's a lot of reason to be hopeful for big advances in the future. And that's kind of where we're coming from. So you hit on the fundamental problem that we're facing, which is that there's this kind of disconnect between our system for diagnosing depression and other forms of mental illness and the neurobiological basis of those illnesses. And whenever I'm talking about this, I always like to emphasize that the current system, the DSM, has really been a transformative, positive thing for a lot of people. It's ensured access to mental health care that people really need, and it's provided doctors with a language for talking about mental illness in a way where we all understand what we're saying. But one limitation of the DSM is that it was never really designed to map directly onto biological processes, because when it first came out, the modern version was released in 1980, and when it was first released, we didn't really have much of an understanding of the biology of mental illness, so there wasn't really an effort to integrate the two. So what we're trying to do is develop ways of rethinking the way we diagnose depression that are grounded in biological measures. And the measure that we're focused on is called resting state functional magnetic resonance imaging. This tool, it's just an MRI brain scan, the same kind of scan that a lot of people would get if you had a concussion or if you had an orthopedic injury. And the scan can be sensitized to the activity of specific brain regions. And over the years, other investigators have found that we can look at the way these activity measures change over time, and those measures can be used to create a map of how different brain regions are functionally connected. And what we and others have found is that these maps are very different in patients with depression than they are in healthy people. And what we're trying to do in the project that you guys have so generously supported is we're trying to combine data sets for many different sites and look at how these maps vary across different individuals and see if we can identify subgroups of depression on the basis of these maps. And if we can, we hope that we can begin to model these subtypes of depression and to develop treatments that target the specific pathologies that are present in these different subgroups. Hopefully those treatments would be more effective and have fewer side effects. That's kind of the 30,000-foot picture and long-term goals.
That's great. Again, it sounds like a really impressive and hopefully very helpful in the long run, or even more near term translational research efforts. So that's fantastic. So let's zoom in a little bit. In your research proposal, you indicate that when you analyzed this massive data set with your colleagues that you had collaboratively compiled, you found 3 distinct depression subtypes emerging from the data, and you indicated in your talk at the IMRO Music Festival for Brain Health in September that this could, even though it's preliminary, the results are very preliminary so far. They indicate there could be a lot of hope for people with depression to get more personalized treatments. How did you feel when you were seeing these patterns from the data emerge? I mean, did you know you're onto something here? I mean, it seems kind of uncanny to see something like that emerge.
Yeah, I have to say it was tremendously exciting, and in many ways the results worked out better than I would have even anticipated. A challenge with these kind of studies is that there is a lot of noise in the measurements that we make. They're not perfectly accurate, and so we don't necessarily anticipate that this kind of approach is going to work so well for diagnosing individual patients. And we found that through a lot of efforts to control for that different forms of noise, that we could develop biomarkers that were capable of diagnosing these 3 different depression subtypes with reasonably high accuracy. But I'll also say, as a scientist, I always approach preliminary results like this with a healthy degree of skepticism. And I think that's especially important when you're talking about work that has the potential to have a real impact on patients, and isn't just kind of abstract pie in the sky. Before it's ready for translation to real patients in a real clinical setting, they need to be replicated. And so I think my feelings right now are cautious optimism.
Okay, sounds good. Sounds good. Now, according to your Rising Star winning proposal, the neurobiological signature of one of these subtypes that seemed to emerge from your data seemed to resemble the debilitating results in the brain of chronic stress. Now, does this discovery seem to suggest that there's even more evidence now for chronic stress as a potential cause of depression? And then part 2 of the question is, does it seem like the other 2 signatures, or the other 2 subtypes that you found, indicate other potential causes of depression specifically?
Yeah, great question. So we've known for a couple decades now from basic kind of neuroscience experimental work that chronic stress can have a whole range of impacts on brain structure and function across a whole range of species. So that tells us that these effects have probably they've probably been present for many years of evolution, and there's probably something really real here that we're trying to measure with a brain scan like fMRI. More recently, we found that brain scans do seem to be capable of detecting changes in those maps of functional connectivity that I mentioned before in the brains of people who are chronically stressed but otherwise healthy, who don't have any form of mental illness. And interestingly, in one of the subtypes of depression that we think we have identified, the changes that we see in those people really closely resemble what we see in chronically stressed people, just like you said. So that's exciting. I think it does. I think the best evidence that stress is related to depression and may contribute to episodes of depression, I think it comes from big epidemiological studies, and so we've known for some years that stress and depression are tightly correlated. That stress can trigger episodes of depression in vulnerable individuals, and I think the best evidence really comes from those big epidemiological studies. But I think this adds to that. Your second question was something that I'm really interested in myself. and that's whether these other subtypes, whether we might be able to infer other causes that may contribute to these other subtypes of depression based on the brain scans. I think one thing that stands out is that, as I said, we think we've identified 3 subtypes. One of those subtypes encompasses about 50% of our patient population. And I suspect that that subgroup probably in itself encompasses multiple other subtypes that if we had a larger data set, we'd be able to identify. And it's, there are not just stress, but many other causes that may contribute to the emergence of depression in vulnerable individuals. Genetic factors are undoubtedly at play. Depression, especially bipolar depression, is quite heritable. It tends to run in families. We don't know exactly what those genetic factors are, but we do know that it runs strongly in families, and so they're likely to play a role. And different genetic factors may contribute to these different subtypes in different ways. That would be kind of one hypothesis that we need to test, and we hope that the study that we're just beginning now, that with your support, will be able to generate data to address that.
Wow. Okay. It kind of adds to the, I want to use the term mystery, but I mean, in a good way, in terms of like it piques my curiosity to see, what your data might reveal when you get more data about what these other subtypes are, the subtypes of the subtypes, coming out.
Absolutely.
So that should be exciting to see. So thank you so much for answering all these questions. And when viewers have questions for you on the Brainwaves page after I post this video online, will you be willing to answer some questions for them?
Absolutely. I'd love to take some questions. I'm looking forward to it.
All right. Thank you so much, Conor. And I'll talk to you soon.
Okay. Thanks for having me, Brandon. Talk to you soon.